factors and multiples of whole numbers. There's a definition here of what a factor is. You probably already know this, but factors are numbers or algebraic expressions that are multiplied to get a product. And then it asks us to find all the factors of 24. So it means whole numbers that you can multiply together to get 24. Yeah, what are some examples? 24 and 1. And when I'm listing the factors, I always like to list them as a pair. So I'm going to say 1 and 24. 3 and 8. 6 and 4. 2 and 12. So we have 1, 2, 3, 4. What about 5? No? And we have 6. What about 7? No. And really, if you do list them in order, it might be a little bit better. So if we went 1 and 24, 2 and 12, 3 and 8, 4 and 6, and kind of listed them that way. Those are all the same numbers. But now we can go, well, we did 1, 2, 3, 4. 5 is not 1. Now we made it to 6. And because we already used 6, I don't need to check any more of the numbers between 6 and 24. Because I know that I've got them all. So if you do them in order, starting with 1, then by the time you go 1, 2, 3, 4, 5 isn't 1, we're all the way to 6. There's not going to be any more between 6 and 24 once you kind of get to that number. So let's look at 75. 1 and 75. Does 2 go into 75?
No.
3? 3 times 25. 4? 5?
Yes.
5 times what? 15. What about 6? No. 7? No. 8? 9, 10, 11, 12, 13, 14. Any of those? I don't think so. So that's just finding factors, which is going to be an important skill in this unit. It's not what we're going to spend a lot of time on, but we're going to be looking at factors of things like 2x squared y. We're going to be looking at more complicated factors and looking for the factors of that. But it starts with this, finding factors of whole numbers. Another thing we need to talk about is prime and composite numbers. And I'm pretty sure you've heard of these before too. A prime number is a whole number with exactly 2 factors, itself and 1. So nothing else divides evenly into it besides itself and 1. Has just 2 factors. A composite number is a number with 3 or more factors. So those numbers that we just looked at, which were 24 and 75, are they prime or composite? Composite, because they had a bunch of factors, right? I want to sort these numbers out into prime and composite. So let's just going to move some of these out of the way. I'm just going to pick one. Oops, I don't want to move that. Okay, 6 is up there by itself. Should I put 6 over here as prime or over here as composite? Composite, right, because it has factors 1, 2, 3, and 6. How about 12? What about 7? Prime. It's only 1 times 7, no other factors, right? 8? 9? Composite. 1, 3, and 9, right? 10? Composite. 11? Prime. 5? Prime. 4? Only Remiel knows anything. What are the rest of you doing? Just letting him answer everything for you? How about 3? Prime. Do you notice I started with the bigger numbers and I'm working my way down because these ones are actually harder. 2? Prime. 1? One's just going to stay there by itself. Well, it does not have exactly 2 factors, 1 in itself. How many factors does 1 have? 1. 1 is its only factor. So it doesn't fit this definition. Composite is a number with 3 or more factors. Well, it doesn't have 3 or more factors either. So we're going to leave 1 out. See, it doesn't fit into either category. One thing that you should notice about all these prime numbers, especially if I cover that one up, they're almost all odd numbers, right? The only even prime number is 2. So if you have an even number, you should know, and it's not 2, you should know right away that it's composite. Because it will always have itself and 1 and 2 as a factor. And here's something a little different. This says, write the prime factorization of 90. And what that means is take 90 and break it down into factors, numbers that multiply together to give you 90, that are all prime numbers. So here's how we're going to do that. Take the 90. What are any 2 factors of 90? 45 and factors. So what would you multiply 45 by to get 90? 2. So 2 and 45. You could pick any 2 numbers to start with. Is 2 a prime number?
Yes.
Yes? Okay, I'm just going to circle it to say, hey, that's prime. How about 45? Is that a prime number? No. Tayson, what are some factors of it? 5 and 5 times what would give you 45? 9. So if the number's prime, I'm going to just circle it. If it's not, I'm going to break it down further into its factors. How about 9? Prime or composite? Composite. What are some factors of 9? 3 times 3. 9 is 3 times 3. And 3 is prime, right? So I'm going to circle those. What about 5? That's prime as well. I'm going to circle that. If I do all of those prime numbers multiplied together, 2 times 3 times 3 times 5, what do I get?
3 times 5?
It would be 90, right. And that's what we wanted. So because we're doing the prime factorization of 90, the prime factorization of 90 is 2 times 3 times 3 times 5. It's all those prime numbers that you end up with after you sort out all of the factors. So 90 equals 2 times 3 times 3 times 5. Or you could write it as 2 times 3 squared times 5. Because there are 2 3's, right? Either of those is the prime factorization of 90. So for writing this prime factorization, can I get somebody's first 2 numbers? What did you have, Madison? 2 times, sorry, what was it? 1650? Now I want to break these down further. 2, that's already prime. What can I do with this 1,650? 50 times what? 33. Okay, is 50 a prime number? No. So 50 could be 25 and 2. Oh, 2's prime, isn't it? I'll circle that. 25 though. 5 times 5. And those are prime, right? 33 is not prime. It's 3 times 11. Both of those are prime. So this is it. We're done. Starting from that 3,300. There are lots of different ways to get here. You might not have decided to do 50 as 25 times 2. Maybe you did 5 times 10. That's okay. You may not have started with those. It doesn't matter. As long as in the end you get this, 3,300 equals 2 times 2, times 3, times 5, times 5, times 11. Notice I'm starting smallest number to the biggest number of the numbers that I've circled. So pick the smallest circled number, which was 2, and there are 2 of those. So put both of those down. And then there's a 3, 2 5s, and 11. That's what you should have ended up with. When you multiply all those numbers together, you get 3,300. You could also write this as 2 squared times 3 times 5 squared times 11. Now you've probably heard GCF before, greatest common factor. This question asks you to determine the greatest common factor of 30 and 48. Not the lowest common factor, the greatest common factor. So what you could do, there's a couple of different ways to do this. List the factors of 30 and list the factors of 48. And then choose what's the biggest number that's in both groups. That might not be that difficult to do for this. Do you want to just try that? See if you can come up with that number? So you've, I'm sure, been shown before how to find a greatest common factor just by listing the factors and looking at which number is in both lists, and the answer here is 6. But if we do a prime factorization, so we take 30 and we can break it down into 3 times 10, and then the 10 into 2 times 5. And we do the same with 48. 48 can be broken down into 4 times 12. The 4 into 2 and 2. And the 12 into 3 times 4. And then that 4 into 2 times 2. You don't have to do it in that order, but this is what you're going to end up with. 30 is 2 times 3 times 5. And 48 is 2 times 2 times 2 times 2 times 3. Right? You can find the greatest common factor by doing a prime factorization. Because now we can look at what's common in the prime factorization. They both have a 2. They also both have a 3. And 2 times 3 is 6, which is the greatest common factor. Six is the greatest common factor. I don't care which of the two methods you use, but this one that I'm showing you here with the prime factorization is going to be useful when the numbers have a lot of factors, and it's hard to know if you listed them all. Like 48 actually has a lot of factors, right? Sometimes if you had another number that also had a lot of factors, it might be hard to know for sure that you have the greatest common factor. It's also going to be useful when we start adding variables into this as well. So we're not just looking at 30 and 48, but maybe we're looking at 30 x squared y cubed and 48 x to the power of 5 y, or something like that. Then this prime factorization is going to become fairly useful. If you do it this way with the prime factorization and you pick out all of the factors that are common to both, then you will always get not just any common factor, but the greatest common factor if you do it correctly. That's the advantage of doing it this way, especially if you're working with big numbers. It ensures that you actually get not just a common factor, like 2 is a common factor, 3 is a common factor, 6 is a common factor, 9 is a common factor, but none of those are the greatest common factor. 18 is the greatest common factor. So we've been talking about factors, now we're going to talk about multiples. Multiples are the product of a given number and a natural number. And it asked us to list the first 5 multiples of 4. So that's just 4 times 1 which is 4. 4 times 2, which is 8. 4 times 3, 12. 4 times 4 is 16. And 4 times 5 is 20. Those are the first 5 multiples of 4. So it's just multiply 4 by 1, multiply 4 by 2, by 3, by 4, and by 5. When you're listing factors, there are a finite number of factors for any number, meaning like there's a certain number and no more, a finite number. But when you're listing multiples, there are an infinite number of multiples. So you would never be asked to list all the multiples of 4. Because you could sit there for the rest of your life listing multiples of 4 and you would never finish, right? So I'm not going to ask you to do that. There are an infinite number of multiples. Just keep going. If I wanted one more, what would I do to get the next one? Just add 4 more, right? Or multiply 4 times 6, then 4 times 7, then 4 times 8. Keep adding 4 and you get more multiples of 4. This question asks you for the least common multiple, or sometimes it's called the lowest common multiple. So it's the smallest number that's a multiple of both 4 and 10. And we're going to do this just by listing the multiples. So if we look at 4, the multiples are 4, 8, 12, 16, 20, 24, 28, and so on. If we start listing multiples of 10, it's 10, 20, 30, 40, and so on. I didn't need that many because what number is common to both lists? 20. 20 is the lowest common multiple of 4 and 10.